In this video, we are going to learn about the applications of trigonometry. The introduction and basics of trigonometry were introduced to you in the previous video, right? Here we are discussing about the applications of trigonometry, the practical aspects, why trigonometry is so important part of mathematics. As we studied earlier, trigonometry is something which has three dimension, right? It's the measurement of the three-dimensional structure, and this three-dimensional structure is basically a triangle, moreover a right triangle, right? This we have studied. For such figures, the measurement of such figures, we can use trigonometry, right? Now let us understand the first application. What it says, astronomers have used it to calculate the distance of Earth to the planet and the stars, right? So the very first application from where the trigonometry originates is the measurement of long distances, right? Planets, stars, okay? Such distance can't be measured with any instrument or any measuring tapes. So this type of distance can be easily measured using trigonometry. Trigonometry is also used in geographical and navigations to construct maps, because so the basic application of trigonometry is related to determining the position as well as the distance and the height, right? Now we will understand the basic, right? What is the basic application of trigonometry which we can see in the daily life, right? So to understand it, we must know that trigonometry is actually used to find the distance, okay, or height of any object. Basically, height and distance measurement. Okay, in this video we are going to discuss how we can use trigonometry to measure height and distance. So we'll first understand few concepts, right? Let us take an example. This is an pole. We have a pole here, right? And some person standing here, right? And he has to measure the distance, right, between this pole and this vehicle. Some vehicle is there, okay? He wants to measure the distance between this pole as well as this vehicle. What is the distance between these two? Now to find this distance, right, this is the angle of dispersion. Here is the angle of dispersion, right? Because it is dispersing, right? And to calculate this, we must know the angle of dispersion, and here it is 90 degree, right? So it forms a right triangle, and trigonometry is used to calculate these distances and the angles, right? We have studied this. So by using trigonometry you can find this distance. If you know this angle of dispersion, angle of depression, actually it is depression, right? It is deviating, it is going down, it's angle of depression, right? Now similarly, if the vehicle is here and if you want to know the height, right? If you want to know the height, right, and this vehicle is here and you know this angle. What is this angle? This is angle of elevation, right? We know depression is something which is low and elevation is something which goes high. So by understanding the meaning of these two words, like depression is something lower and elevation is something which increases or goes high, so by this you can understand this is angle of depression and this is angle of elevation. Now we'll see with an example, right, how we can calculate the distance and height. Now let us take an example and it will be an interesting one. See, if you want to calculate height and the distance. Everyone knows Eiffel Tower, right? See, this is an Eiffel Tower. And here you are standing somewhat here, okay? And you don't know what is the height. You don't know, okay? You don't know what is the height. And you don't know what is the distance. If you know this distance, right? If you want to calculate this height and you can't climb and calculate the height, you don't have to calculate, okay? You don't have to climb. You can't climb, okay? You can't climb on this Eiffel Tower. And now you have to calculate what is the height of this Eiffel Tower, right? And you have to calculate this also without walking, that what is the distance. You don't know what is the distance. You also don't know what is the distance, right? So for solving such questions, what you have to do, you have to know and you must understand the concepts of trigonometry, okay? Now what you can do, if you know this distance is somewhat, okay, if you know this distance, okay, you know this distance is actually 60, okay, say it's 60, right? Now you can calculate the height. How you can calculate? See, you know sine 45 degree, okay, this is the angle, is actually equals to the perpendicular, okay, perpendicular divided with the hypotenuse. You know this thing. This perpendicular is actually the height of Eiffel Tower, you know, in this question. And this hypotenuse is given to you as 60 meters, okay? Okay. You know what is the value of sine 45? It's 1 by root 2. You know this, right? This is, we have studied, this is a constant angle, right? 45. And this is the height of tower, 60, right? Now you know what is the height of Eiffel Tower. It is 60 by root 2 meter, okay? So by using this trigonometry form, you can calculate the height of Eiffel Tower. Now next, for the distance, you have to calculate this distance without actual walking, right? You can't walk, you have to calculate it. Similarly, you can go with cos, right? We know that cos theta is actually equals to base by hypotenuse, right? See, your base is this because this is forming 90 degree as well as theta, okay? This is your base. You know cos 45, and here you have to write the base. Base is actually the distance, and hypotenuse, you know, it's again 60. You know cos 45, it's 1 by root 2, and distance by 60. So it comes out to be as distance is 60 by root 2 meter. So this is how we used to calculate the heights and distance using trigonometry. Hope this basic example will help you to solve all your questions. Thank you for watching.